And we're live recording, talking about parametric constraints for cams in motion. So Mikayla, you have modeled your eccentric cam here, and you've got some additional sketch lines in there. Why the blue lines, or what were you able to figure out with the sketch lines?
Alright, so with the sketch lines, to get them to certain degrees, it's basically just some quick commands in sketch mode. So if I delete this just to do it new, you just click the face, and then start a sketch, L for line, and then from the center of this circle, you want to drag out, and then you want to make sure it's, so if your cam isn't directly on the X and Y lines, it's gonna be a bit difficult, but you can still do it. So start from the middle, drag out a ways, and then you hit tab to get to the second one, and then just enter it in as 0 degrees. That's your baseline, and then you have this nice little line. You can go again, click there, drag out, tab 45 degrees, or however many you want, hit enter again, and then you get more lines.
Naming it, keep going.
And then you can basically do that all the way around, 90 degrees, and then another one, that's 135 degrees, and then you just keep going.
We're going to let you finish because it's just
180.
Poetry in motion right now.
I like motion.
Who said that?
135.
Take an English class. You're kicked out. No, I like haikus actually.
I like
90
motion.
degrees.
And the
And
last
then
one, tab and
45.
Right, okay.
And to make it look pretty, you just click your T for trim.
Okay, that's important. T for trim. And why are we trimming these back? What is this going to tell us, people? What can you see where we're going with this?
To make it look pretty.
No.
It makes it look pretty, and it tells you the dimensions of the line.
Oh, the more critical part. We need to know. Remember when that scatter plot graph? What is the distance from the center of that axis? And how is that different as the cam goes around its revolution? So she just created a line to all those critical measure points, and now she's got a measurable line.
If you just click on it, you can see how long it is.
Just show, can you do the inspect tool too? If she selects it, it tells you, but she can also do select and a measure, and it will tell us right down the bottom right-hand corner, 0.644. Now that is at, what's the degree there? You can pick anything, but from a certain start point, which one are you going to call 0?
So the one already going to this right is set at 0, because you can see there's 45 here and
Okay.
135, and that's what most of the measurements are based off of, is this line going to the right.
Now, I would like all of you, and she could easily redo this, I'd like you to make your 0 the one that is closest to the axis, or like our I think it would be top dead center. So the one that's closest here. If you made that your 0, 0 equals, for this length on the bottom, Mikayla, what do we have for this bottom one? 0.25. So she can take those two numbers and she can throw those into a spreadsheet, a couple cells in a spreadsheet right now. 0 degrees equals 0.25 inches. Then she would say 45 degrees, which is the next number, equals 0.291. So now we've already got that rise at 45 to 0.291. 90 degrees is going to be equal to whatever this next one is. 0.433. No, right there, whatever that is. How many of you get where we're going here? Thumbs up. You can see it now. So that sketch is just a practical measuring tool. If we had to do this another way, like physically make the cam and try and measure displacement, it'd be very difficult. The program allows us to do this with relative ease. So just to show them that it's possible, do you want to show off the other ones you created as well?
I actually did all of them. Here's the pear cam, and then hexagon, and then the snail was a bit hard because you had to shape it yourself.
And that is
That's what I
100%
did.
correct. I couldn't have given you a direct instruction like Mr. Shasha talked last week. We're getting into this world of sometimes you just have to kind of go by feel, or like, well, I think it should be like this, or you're saying with that view you had to just make up some of the curves, right?
Yeah, basically this whole outer line is a big spine that I just edited by hand.
By hand, and did like 3-point splines or whatever to get to where you needed to be. It's going to work. It's just going to have some custom kind of, like, look at right here. It goes a little bit over the largest point, so it's okay. It's a custom cam. She actually designed a custom snail cam. Now the profile of that and mapping that is what we're going to challenge ourselves with next. Visually in your mind, what do you see the profile of that doing, and how will that map out in a spreadsheet? Now, Brandon, if you modeled all 4 and made an attempt, and in Mikayla's case, I want to recognize extra effort with extra credit. I can certainly bump the grade extra credit-wise if you've done all 4 correctly. That's cool. I only ask that you model 2 of the 4, and then we're going to map those 2 in a graph. And she's going to get started on that today and probably hammer that out. And we'll put it all together, make it look pretty, put it in our engineer's notebook and make it presentable. Any questions for Mikayla on this before we stop the recording, or any questions otherwise? Okay, so this is really where we're going next with these. If you haven't modeled them yet, you're in a little bit of a time deficit. Get going on that. Use the sketch tool to create some points to measure to. And we've got at least one expert in the room that can help if needed. Very cool. So jump up to the top here and hit stop recording. Boom.